Good evening all. Today we will start question number 20. So what is question number 20? F of x is equal to, given that we can take it as x square minus sin x plus 5. So f of x equals to x square minus sin x plus 5. We are going to check the function is continuous at x equal to pi or not. So if it is continuous at x equal to pi means we have to find the limit of the function and we have to find the value of the function, and we have to finally say limit of the function equal to value of the function. So now we'll find the left hand limit at x equal to pi. So LHL at x equal to pi. So in this case, what is my f of x? It is same as x square minus sin x plus 5. So left hand limit definition, limit x tends to pi minus f of x is equals to limit h tends to 0 f of pi minus h, f of pi minus h. So f of x value already I have. So substitute f of pi minus h, that is replace a pi minus h in the place of x. So I will get pi minus h whole square minus sin of pi minus h plus 5. So this sin a minus b formula, using sin a minus b formula, I can expand this. So I am expanding means this will be same pi minus h whole square. This will be minus of sin a cos b minus cos a sin b plus 5 will be remaining. So now we will simplify this. Value of sin pi equal to 0, sin 80 equal to 0, cos pi equal to minus 1, or we can keep as it is and then we can apply limit, anything I can do. So I am simplifying and keep. So pi minus h whole square minus sin pi is 0, so this term will become 0, cos pi equal to minus 1, so this will be sin h. So sin h plus 5, or one more method we can use, sin 180 minus theta sin theta, that also we can use, both also equal. Now apply limit h tends to 0 f of pi minus h is equal to limit h tends to 0 f of pi minus h value is pi minus h whole square minus sin h plus 5. So applying h equal to 0, we will get pi square, h equal to 0, sin 0 0 will come, plus 5 will be remaining. It is our LHL. So what about RHL for this function? RHL, right hand limit at x equal to pi. So here also same f of x, that is f of x equal to x square minus sin x plus 5. So I need to apply the right hand limit definition. Limit x tends to pi plus f of x is equals to limit h tends to 0 f of pi plus h. So already I have the value of f of x, so I need to find the value of f of pi plus h. So f of pi plus h means I will get pi plus h whole square minus of sin of pi plus h plus 5. So here I am not going to expand, we are going to use the sin 180 plus theta. Sin 180 plus theta is which quadrant? For third quadrant. 180 plus is third quadrant sin is negative, so it will become minus sin theta, already minus there, so it will become plus sin theta plus sin h plus 5. Now apply the limit h tends to 0 f of pi plus h equal to limit h tends to 0, we will get pi plus h whole square plus sin h plus 5. So now apply limit h equal to 0, we will get pi square, here sin 0 0 will come, plus 5 will come. So my RHL is equals to pi square plus h. LHL equal to pi square plus h, r square equal to pi plus h. Similarly, what is the value of the function at x equal to pi? F of pi, replacing x in the place pi, I will get sin square minus sin pi plus 5, which is equal to pi square plus 5. So LHL equal to RHL equal to value of the function. So I can decide limit of the function. Limit extends to pi f of x equal to value of the function f of pi. Therefore I can say that f is continuous at the point x equal to pi. Clear? Next question, 21st question we will see. In the 21st question it is given that sin x and cos x given. So we will prove the continuity of sin x and cos x first, and then we will execute the problem number 21. Question number 21. So question number 21 is given that discuss the continuity of the following functions. The first one is given that f of x equal to sin x plus cos x. So 21st question, first one we are going to check the continuity of the function f of x is equal to sin x plus cos x. So continuity at every point we are going to check. So what I am going to do means, first I am going to prove the continuity of the sin x, and I am going to prove continuity of the cos x, and then finally I am going to use theorem 1, and then I am prove sin x plus cos is continuous. So how to prove sin x is continuous? So we can take it as, let g of x is equal to sin x. So I am going to prove the continuity at x equal to a general point, because it is x means it is continuous everywhere, means infinite number of points are there. I am not going to prove any point every point, so I am taking a particular point. So let x equal to a, I am going to prove it is continuous. So now what is the limit of the function? Limit extends to a minus, that is left hand limit extends to a minus f of x is equal to limit h tends to 0 f of a minus h. So what is the value of f of x here? That is, we have used g, so we can use g of x, g of a minus h. So g of x value equal to sin x. So what is g of a minus h? G of a minus h means sin of a minus h we will use. So what is the function for sin a minus h? So we will use the formula for sin a minus b. So sin a minus b equal to sin a cos b minus cos a sin b. So I am using sin a cos h minus cos a sin h. Now apply the limit. So limit h tends to 0, g of a minus h equal to limit h tends to 0, this value, that is sin a cos h minus cos a sin h. So we can split the limit which is independent of h, that we can take outside. So sin a is independent of h, it is taken outside, remaining limit h tends to 0 cos h minus, similarly cos a is independent of h, cos a taken outside, remaining limit h tends to 0 sin h. Now applying cos h equal to 0 means cos 0 1, so I will get sin a minus, I am applying h equal to 0 means sin 0 0, so my LHL equal to sin a. What about RHL? So RHL, here f of x value is also same as that is g of x. G of x value is also same as sin x function. Apply limit, apply the definition of right hand limit. Limit x tends to a plus f of x. Limit x tends to a plus g of x. G of x equal to limit h tends to 0, g of x value I have to replace x plus, that is a plus h. A plus h generally I need to replace. Now I need to find the value of g of a plus h. So g of a plus h value is equal to what? G of x equal to sin x means g of a plus h equal to sin of a plus h. Now I will find the expansion of this value, that is sin a cos b. Expansion of sin a plus b is sin a cos b plus cos a sin b. Sin a cos b plus cos a sin b. Now apply the limit. So limit h tends to 0, g of a plus h is equals to limit h tends to 0 sin a cos h plus cos a sin h. Now split the limit and apply. So limit h tends to 0. So what is independent of h here? It is sin a, that I can take outside and apply limit. So that is sin a into limit h tends to 0 cos h. Similarly cos a is independent of h, so cos a will be taken outside, remaining limit h tends to 0 sin h. Now apply limit h equal to 0 cos 0 equal to 1, so that will be sin a. Second term as well as second term it will be. Now the second term will be applying limit, means we will get second term cos sin 0 0 will come, 0 will come. So my RHL is equal to sin a. So LHL equal to RHL I got. Now what is the value of the function f of a, that is f of a I can replace, that is equal to sin a. So therefore LHL equal to RHL equal to value of the function. Therefore we can say f of x is continuous function. F of x and continuous function. Next I need to prove the continuity for cos x. Like similarly continuity of cos x. So we are taking, already we have taken f of x and g of x. So I am taking s of x. So let s of x equal to cos x. I am going to prove the continuity of the cos x here. So after that I am going to merge add that sin x plus cos x. I am going to say sin x plus cos continuous and sin minus cos continuous, like that. So now we are going to prove the continuity of the cos x at general point. So I am taking let x equal to a. It's continuous everywhere I need to prove. So let x equal to a, s of x equal to cos x. Now LHL of the LHL of the cos x at x equal to a. So the definition of LHL is limit x tends to a minus s of x, limit x tends to a minus f s of x equal to, we can write s of x equals to limit h tends to 0 s of a minus h. Then we will take the limit. So first find the value of s minus a. So what is s of x? S of x equal to cos x. So s of a minus h means replace x in the place a minus h. So cos of a minus h will come. So expansion of cos a minus h, I will write cos a minus b equal to cos a cos b plus sin a sin b. Cos a cos b plus sin a sin b. Now apply the limit x h tends to 0, limit h tends to 0 cos of a minus h equals to limit h tends to 0 cos a minus h value we are going to apply now. So cos a cos h plus sin a into sin h. Now applying limit h, what is the independent of h? Independent of h we have to take outside. So I am taking cos a outside, it is independent of h. So cos a will be taken outside, remaining limit h tends to 0 cos h plus sin a will be taken outside, limit h tends to 0 sin h. So applying h equal to 0, cos 0 equal to 1. So we will get cos a into 1 plus sin a, sin 0 0. So we will get sin a into 0. So the total value LHL equal to cos a. So this is my LHL. So what about RHL? Definition of RHL we will write first. Definition of RHL equal to definition of RHL is equals to limit x tends to a plus s of x is equals to limit h tends to 0 s of a plus h. So what is the value of s of a plus h? Already we have s of x equal to cos x. So substitute s of a plus h. So we will get cos of a plus h. Now write the expansion of this one. We will get cos a cos b minus sin a sin b. So now apply the limit for this. Limit s of x h tends to 0, s of a plus h equal to, apply limit here also. So we will get limit h tends to 0, the total value cos a cos h minus sin a sin h. Now independent of h we have to take outside. So cos a is independent of h. The remaining will be limit h tends to 0 cos h minus similarly similarly second term also independent of h is sin a. So sin a will be taken outside. Remaining limit h tends to 0 sin h. So now apply limit cos 0 1 will come. So as usually we will get cos a minus 0 will come, that will be equal to cos a. So my RHL is equals to cos a. LHL already I got, LHL equal to cos a. So LHL equal to RHL. We'll find the value of the function s of a. So s of a also is equals to cos a. So limit of the function is equals to value of the function. Limit extends to a cos x, or we can write limit extends to a s of x. Limit extends to a s of x equal to s of a. Therefore f is continuous. Therefore f is a continuous function. Now we have proved that previous case sin x is continuous. In this case cos x is continuous. Clear? Now I am going to use theorem. From that theorem I am going to say sin x plus cos x is continuous. Now theorem 1, page number 156, the theorem is given. Page number 156, our textbook theorem 1 is given. What is theorem 1 means? F is a continuous function and g is a continuous function on a real number c, means we can say that f plus g is continuous. Similarly f minus g is continuous, and third case f into g is continuous, and finally we can say that f by g also continuous. F by g is continuous except g of x equal to 0, that is you have to take g of x not equal to 0. So f is a continuous function, g is a continuous function, means f plus g also continuous, f minus g is continuous, f dot g is continuous, f by g is continuous. So from that we have already proved cos x is continuous function. So sin x is continuous function. We know that actually we have proved sin x and cos x. So we know that sin x and cos x are continuous functions. We know that sin x and are continuous. So we can say that the first question, actually the question number 21. So a question is given that f of x equals to sin x plus cos x. So already we have proved sin x is continuous, cos x is continuous. So sum of two continuous functions is continuous. Therefore we can say f of x is continuous. Similarly question B is given that, what is given question B? F of x equal to sin x minus cos x. So f of x equal to sin x minus cos x. We know that sin x continuous, cos x continuous. By theorem 1, difference of two continuous functions is also continuous. Therefore I can say that f of x is continuous. Similarly question C is given, f of x is equal to sin x into cos x. So sin x into cos x. So by theorem 1 we know that f is continuous, in g is continuous, means f dot g, f into g is continuous. Similarly sin x is continuous, cos x continuous, so multiplication of two function is also continuous, therefore we can say that f of x is a continuous function or f of x is continuous. Clear? Okay, thank you all. Next class we will see question number 22, 23 and 24. Thank you.